Hey everyone, thanks so much for tuning in today. Before we dive into this incredible story locked in ice, I want to take a second to genuinely wish you all the very best. I hope you're feeling healthy, energized, and ready for a fascinating journey into our planet's past. Okay, let's get started. Imagine you could find a time capsule, not buried in your backyard, but hidden deep beneath the vast, frozen surface of Antarctica. This isn't a box with old photos or letters, it's something far more remarkable. Scientists have discovered that the thick ice sheets covering Antarctica act like giant, natural history books. By drilling down and pulling up long, cylindrical samples called ice cores, they can unlock secrets about Earth's atmosphere and climate from tens of thousands, even hundreds of thousands of years ago. It's like having a direct line to the air our planet breathed long before humans built cities, or even before ancient civilizations arose. How is this possible? Well, it all starts with snow, pure, Antarctic snow falling year after year, century after century, millennium after millennium. When snow falls in Antarctica, especially deep inland on the high, cold plateaus, it doesn't always melt away like it might where you live. Instead, it just piles up, layer upon layer. Each winter adds a fresh blanket. Over time, the weight of all the snow above presses down relentlessly on the layers below. This immense pressure, combined with the natural cold, slowly transforms the lower, older snow. The delicate, fluffy snowflakes get squeezed, their intricate shapes collapsing. Gradually, over decades and centuries, that compressed snow recrystallizes into solid ice. Now, here's the magical part trapped within this process. When the snow was still loose and fluffy near the surface, countless tiny pockets of the surrounding air became trapped between the snowflakes. As the snow compressed and turned to solid ice, those air pockets didn't just vanish. They got sealed inside, becoming tiny bubbles of ancient atmosphere, perfectly preserved like microscopic fossils in the ice. Think of each ice core as a vertical timeline. The very top of the core represents ice formed from snow that fell just recently, maybe a few years or decades ago. As you look further and further down the length of the core, you're looking at ice formed from snow that fell longer and longer ago. It's literally a journey back in time, with the deepest ice holding the oldest secrets. Scientists use incredibly powerful drills, sometimes operating in brutally cold and remote conditions for months, to extract these cores. They can drill down thousands of meters, recovering ice that's hundreds of thousands of years old. Handling these cores requires extreme care. They are precious, frozen records, transported to specialized laboratories around the world in freezers to keep them perfectly preserved. Once safely in the lab, the real detective work begins. Scientists cut sections of the ice core with precision. To get to the ancient air, they have ingenious methods. Sometimes, they place a chunk of ice inside a sealed, cold chamber and carefully crush it under vacuum. As the ice breaks apart, the long-trapped air bubbles finally burst open, releasing their gaseous contents, air that hasn't circulated freely on Earth since prehistoric times. This released gas is then sucked into sophisticated instruments for analysis. What are they looking for? Primarily, they measure the concentrations of specific gases, especially the ones we know play a huge role in our planet's climate. Two of the biggest stars in this investigation are carbon dioxide and methane, often called greenhouse gases because they trap heat in the atmosphere. By analyzing the tiny amounts of these gases within the ancient air bubbles, scientists can build a precise record of how much carbon dioxide and methane were present in Earth's atmosphere thousands of years ago. They can see how these levels changed naturally over time, long before humans started burning coal, oil, and gas on a massive scale during the Industrial Revolution. This historical record is incredibly powerful. It shows us, for instance, that over the past 800,000 years, a period covered by some of the longest Antarctic ice cores, natural cycles of ice ages and warmer periods, called interglacials, were always accompanied by rises and falls in carbon dioxide and methane. When the Earth warmed up naturally coming out of an ice age, carbon dioxide and methane levels in the atmosphere also rose. When it cooled back down into an ice age, those levels fell. The gases and the temperature were closely linked partners in the planet's natural rhythm. But the ice doesn't just tell us about greenhouse gases. It captures other clues too. Volcanic eruptions, even ones happening on the other side of the world, spew vast amounts of ash and sulfur compounds high into the atmosphere. Winds can carry these tiny particles all the way to Antarctica. When they fall out onto the snow, they leave distinct, often microscopic, layers within the ice core. By finding these layers and analyzing the chemistry of the trapped particles, scientists can identify specific volcanic eruptions, sometimes pinpointing the exact year they happened centuries or millennia ago. This helps date the core more accurately and also tells us about past volcanic activity and its potential impacts on climate. Dust particles trapped in the ice also tell stories. Higher amounts of dust often indicate windier, drier periods on continents far away, like Australia or South America, giving clues about past wind patterns and aridity. Furthermore, the ice itself holds a record of past temperatures. Water molecules are made of oxygen and hydrogen atoms. Not all oxygen atoms are identical, some are slightly heavier than others. The ratio of these heavier oxygen atoms to the lighter, more common ones in the ice molecules changes subtly depending on the temperature at the time the snow originally fell. Warmer ocean water leads to more evaporation of water containing the heavier oxygen, which eventually falls as snow in Antarctica. Colder conditions mean less of the heavy oxygen makes it into the Antarctic snow. By meticulously measuring the ratio of these different oxygen atoms, a technique called oxygen isotope analysis, along the entire length of the ice core, scientists can reconstruct a remarkably detailed history of how temperatures changed in Antarctica over the vast timescales covered by the core. They can see the slow, rhythmic swings between ice ages and warm periods, and even spot shorter-term fluctuations. Putting all these pieces together, the greenhouse gas levels from the bubbles, the temperature record from the ice itself, the volcanic ash layers, the dust concentrations, allows scientists to paint an incredibly rich picture of Earth's past climate system. It shows how all these elements interacted naturally over hundreds of thousands of years. This natural baseline is absolutely crucial. Why? Because it provides the essential context for understanding the changes happening right now. When we compare the carbon dioxide levels measured directly in today's atmosphere, around 420 parts per million, to the levels found in those ancient air bubbles, the difference is staggering and unprecedented. Over the past 800,000 years, carbon dioxide naturally fluctuated between about 180 parts per million during ice ages and about 280 parts per million during the warmest interglacial periods. Today's level is far, far higher than anything seen in that entire record, and it's rising rapidly due to human activities. The ice core record proves that what we are doing to the atmosphere by burning fossil fuels and cutting down forests is pushing the planet into uncharted territory, breaking free from the natural cycles that governed Earth's climate for millennia. So, the next time you see a picture of Antarctica, remember it's not just a silent, frozen desert. Deep within its immense ice sheets, it holds a priceless archive, a frozen library containing volumes of Earth's atmospheric history written in layers of ice and tiny bubbles of ancient air. These ice cores are more than just scientific curiosities. They are fundamental tools that shout a clear message from the past. They show us the profound link between greenhouse gases and climate, reveal the planet's natural rhythms, and provide undeniable evidence of how dramatically human actions are altering our atmosphere and climate system. By understanding this deep history trapped in the Antarctic ice, we gain the knowledge and perspective we desperately need to make informed decisions about our planet's future. It's a testament to the power of science to uncover the Earth's secrets and a sobering reminder of the unique responsibility we hold as the generation currently shaping the atmosphere for millennia to come. Thanks for exploring this amazing journey through time with me today.